Alright, so this question is about angular momentum. Very interesting question and a very nice question for students who want to practice angular momentum. Okay, so whatever, you can read the question first. You can see that the situation is that there is a force acting at a point which is having a position vector of r, and the question is, what is the value of alpha for which angular momentum about origin is conserved? So we want the value of alpha for which the angular momentum remains conserved. So let's demystify what exactly is being asked. Okay, I hope you have read the question. I will reduce the size of the image. You can refer to that. All right. So I hope you can see the board now. All right. There is a wire which is going on here. Okay. So sorry about this wire. I will just see if I can remove it. Okay. Let it be there. All right. So let's look into this problem. Okay. Now, if you notice, the question says that the angular momentum is conserved. Okay. Generally, when you're given, so we want L to be conserved, right? We want L to be conserved. Okay. Let's do a reverse thinking. When is the L not conserved? Okay. L is not conserved when you have torque, right? So if you have torque, torque is given by dl by dt, right? So angular momentum is not conserved when torque is applied. So if I put the rate of change of angular momentum to be 0, okay, right? What am I trying to say? I'm trying to say that L is a constant, right? So L is a constant. That means it is conserved, it does not change. And if I take dl by dt, this is going to be 0, right? So dl by dt is 0, implies that torque is 0, right? Because torque is equal to 0. So rate of change of angular momentum is 0, means L is constant, being conserved, and the torque is there is no torque. Torque is 0, right? So let's also see. Now we've understood what does it mean. Angular momentum is conserved means the torque does not exist, because torque will result in rate of change of angular momentum, which is not the situation. So let's talk about the angular momentum and how does it relate to F and R. Now we know L is constant and the torque is 0, but we are given F and R. Now how do I link these two, right? That's a question. So remember, torque is given by R cross F, right? This is the vector product. Okay, so if you can rewrite this as modulus of R, modulus of F, and sine theta, which is the angle between them. This is a kind of refresher for you when it comes to angular momentum. Okay, so we know we are given F, the force in Newton, and we're also aware of this particular quantity, which is the position vector where the body is located. Okay, so if I were to apply this, I am saying this is equal to 0. In our case, what we're given is a ijk coordinate system. We are exactly not given modulus of R. We can apply this also, but I think the easier approach is that the vector product, which is your L. Okay, so first of all, I have to write I have to write j, k, and then I have to write 2 because it is R cross F, not F cross R. Okay, so this is minus 6, this is minus 12, and this is alpha 3 and 6. Okay, now we know torque is 0, right? So I'm going to put torque is equal to 0, which is this. Okay, the vector product is 0 of R and F, means the angular momentum is conserved. Okay, let's solve this. So if I solve this, this is what I get, right? So I will say I, okay, the standard way, 6 6 are minus 36, this is minus plus 36, and then I put minus, this is, okay, so this is your 0i, and then I have to write minus j, okay, so minus j, so 12 plus 12 alpha, and then I have to write the k part of it, right? So this is your k, right? So this is your k, right? So this is plus k, and 3 2s are 6, 6 plus 6 alpha is equal to 0. Now we already know that this quantity is 0, minus 36, so this is 0i, this is minus j, and 12 plus 12 alpha, okay? So plus k, this is 6 plus 6 alpha is equal to 0. Now we know, see, this vector should have come out to be a 0 vector. So which means if I use this or this equation, 12 plus 12 alpha is equal to 0, or 6 plus 6 alpha is equal to 0. In both the cases, I get alpha is equal to minus 1. So if you note the choices, I think the last choice which is given is minus 1. So the value of alpha is minus 1. Do not forget to subscribe to this channel. We are giving proper explanation with detailed concept. Okay, this is not just solving a problem and that's about it. This is actually explanation which will help you score high, very high in your examination and reduce your stress, because the conceptual understanding you're getting is very good. Okay, so thank you very much for your time today, and look forward to see you soon. Bye.